if I start talking to a slide that doesn't exist, that's because I can't see it. So we'll go on. In line with the theme of BABE, I'm just going to give you some examples. Oh, you can't hear me? I'm going to give you some examples of material that we've measured as far as their appearance in serum, and we've looked at their bioactivity. So we're trying to answer the question of whether bioactivity and bioequivalence correlate or not. So this has come because there are many new delivery systems that are being developed, and we've worked on transdermal delivery for proteins and peptides, and also an oral delivery for proteins and peptides. There are also many biosimilars that are being delivered, some of which have got various types of glycosylation, and also there's an increased use of drug targeting now as a strategy for therapy. So how do we determine the true bioequivalence of these molecules? And do the blood levels that we might measure, do they correlate with bioactivity? And should bioactivity really be the deciding factor rather than whether you can measure the material in serum? So I'm going to give you 3 examples of this. One was a topical anti-TNF molecule that we've delivered, topical insulin, and an oral anti-TNF molecule. We're going to have a look at the correlation between what we can measure and the bioactivity. And I'm going to tell you the take-home message is it depends, which is a good answer to most questions. Depends upon the molecule and the route, and then we can have a little discussion, or you can think about this afterwards. So we'll go on to the transdermal or topical delivery first. So we're currently developing a water and oil microemulsion system for proteins. It can deliver oil and water-soluble molecules through the skin, so you apply it on the top of the skin. There's no device or anything that goes through. We have no penetration enhancers, and so you can compare this to all the sophisticated microneedles, lasers, etc., or ionophoresis that's around. It's easy to rub on as an oil, and any of you want to come and see it rubbed on, I'll rub it on me later on afterwards. And I'll give you 2 examples. There's anti-TNF molecule, and we'll look at some work we did on topical weight loss with growth hormone releasing peptide, IGF-1 and insulin. Yet the topically applied material is working just as well in the joint as if I applied this material subcutaneously. So, what are the things to note? There was little material of the topically applied material in the blood, so we would have said it was bioavailable, and the blood test would say no. And that would cause you concern. However, if we looked at the bioactivity was the same. So the measurement of blood levels may be misleading, as it doesn't look as though this technology works. But if we don't want the material to be active in the blood, which we really don't for something that's working in the joint, we want it to be active in the tissue, so we want it to get to the site. So it's still got the site where we want activity. So now I'm going to have a look at something slightly even more dramatic. We're going to compare 3 peptides, GHRP6, which is the growth hormone releasing peptide, IGF-1, which is one of those things that stimulates from growth hormone and insulin. We're going to compare them subcutaneously or topically, fine for 14 days. And what we've done here is we've looked to see whether we've changed the muscle mass, one is in the back leg, the muscle growth, and look at the fat to see what's happened to them. So we'll look at the standard biodistribution. Is this the same? So if you look for insulin here, on this we've compared subcutaneous, which is the red bars, to the topical, which is the purple bars. And you see, as we found before, there's very little material, here's the classic subcutaneous in the red, but if you look at the purple, there's very little material that you would have actually measured. If you'd measured in serum, you would have said it wasn't there. But you can see that the material's still in the skin, there's a little bit in the muscle. So it's not really, it doesn't look as though it's bioavailable. Did it do anything? Here we have a comparison of the leg weight. Now, all of these top markers here are all the leg weight from the topically administered material, and these bottom open symbols are leg weight from the subcutaneously administered materials. So here it looks like the topical administration has been anabolic for this, where it hasn't been anabolic for subcutaneous. Here's a significant, here's a significant difference. So topically applied material significantly increased the mass of the muscle, the mass of the muscle in these, whereas the subcutaneously applied material didn't do it.